Hey geologists, so guess what? Miss Bazango got a new webcam. It's still a little laggy. I think it's just because of my internet, so you're going to have to deal with it for a little bit. But let's go ahead and get started. You have officially moved on to the last set of notes over rocks, the types of rocks at least. You'll get into the rock cycle later, but this is just the type of rocks. So today we're going to talk about metamorphic rocks. The third kind we haven't talked about. We talked about igneous and we've talked about sedimentary, but not metamorphic yet. So on that note, let's go ahead and get started on reading some metamorphic rocks. So I'm on page 114 in your books. What are metamorphic rocks? You may be surprised to learn that heat can change a rock like an oven changes raw cookie dough. But deep inside Earth, both heat and pressure are much greater at than at Earth's surface. When great heat and pressure are applied to rock, the rock changes both its shape and its composition. Any rock that forms from another rock as a result of changes in heat or pressure, or both heat and pressure, is a metamorphic rock. So I'm going to make sure I put that in my notes about metamorphic rocks. A metamorphic rock is, as the notes told us, it's any rock that forms from another rock as the result of changes in heat or pressure. Any rock that forms from another rock as the result of heat or pressure, or both heat and pressure. And then there was another part. No, that's it. Okay. So any rock that forms from another rock as the result of heat or pressure, or heat and pressure. Okay, so now that we know what metamorphic rocks are, let's talk about their formation a little bit. So, how metamorphic rocks form. I'm going to put that in my notes. How metamorphic rocks form. Okay. Metamorphic rock can form out of igneous, sedimentary, or other metamorphic rock. Many metamorphic rocks are found in mountains or near large masses of igneous rock. Why are metamorphic rocks commonly found in these locations? The answer lies inside Earth. So, that first paragraph, I want to make sure that I put that a metamorphic rock can form from an igneous, sedimentary, or another metamorphic rock. So, metamorphic rocks can form from igneous rock, sedimentary, or other metamorphic rocks. Because that's really important. It's very different than what igneous and sedimentary rocks have been. The heat that can change a rock into metamorphic rock can come from pockets of magma. For instance, pockets of magma can rise through the crust. The high temperatures of these pockets can change rock into metamorphic rock. Collisions between Earth's plates can also push rock down towards the heat of the mantle. Okay, so now we know that heat can change metamorphic rocks. So let's make sure we put that in our notes. So the heat can change... So, heat can change a metamorphic rock. Oops, wrong one. Can change a rock into a metamorphic rock, sorry. Can change a rock into a metamorphic rock from pockets of magma. So, heat can change a rock into a metamorphic rock from, let's do when pockets of magma. I always change my mind. When pockets of magma come into contact with the rock. So then, another way that heat does this is It said collisions between Earth's plates can push rock down towards the heat of the mantle. So collisions of, I spelled collisions wrong, of Earth's plates can push a rock down into the heat of the mantle. So you're probably, if you guys have talked about tectonic plates before, or the plates on the Earth that kind of shift and move around, that's what they're talking about. So when these two tectonic plates hit each other, it like pushes the rock down into the Earth, which is what causes the rock to come into contact with the mantle. And remember, the mantle is that middle section of the Earth. You have your crust, the mantle, and then the core on the inside. Very high pressure can also change rock into metamorphic rock. For instance, plate collisions cause great pressure to be applied to rocks while mountains are being formed. The pressure can deform or change the physical shape of the rock, as shown in Figure 1. Also, the deeper that a rock is buried in the crust, the greater the pressure on that rock. Under very high temperature or pressure, or both, the minerals in a rock can be changed into other minerals. At the same time, the appearance, texture, and crystal structure of minerals in the rock change. The rock eventually becomes a metamorphic rock. So let's talk about pressure then. So, very high pressure can also change a rock into a metamorphic rock. And the example that they gave us was when plate collisions cause great pressure when mountains are being formed. So plate collisions can cause great pressure on a rock while mountains are being formed. So if you think about it, when mountains form, it's because plates have come together and pushed up the Earth, and that's what happens is these plates are colliding with each other, having a collision, and that pressure that's happening when those two plates collide is what's causing the rock to change. So one of the things that we need to make sure we put is that under very high temperatures or pressure, or both, the minerals in a rock can be changed into other minerals. So under extreme heat, pressure, or both, the minerals in a rock can change into other minerals. And then it talks about how the appearance, texture, and crystal structure of the rocks change. The appearance, I forgot what the other ones were. The appearance, texture, and crystal structure. Texture and crystal structure change of the minerals change. So it's kind of important to know that those are the things that change in that mineral. That's what causes it to become something different. So, and then it does talk about Figure 1, so I'll take you down that. That's not Figure 1. Yeah, it is. This is Figure 1. So this is deformed metamorphic rock. And you can kind of see, we're going to talk about this here in a little bit, how it's got these weird squiggly lines. We're going to talk about that in the next video, so I'm not super concerned about it right now. But this is an example of a metamorphic rock. So on that note, guys, good luck, and I'll see you in a little bit.